Hello guys, today I'm going to explain about iron carbon diagram. This is the iron carbon diagram appearing on the screen. Actually, we have different types in this is the form from where iron is. When we add carbon to iron, when we add carbon to iron, then iron carbon diagram is formed. During this process, four types of process we have seen, and I am going to explain about the four types of processes. The iron carbide diagram begins with iron and ends with iron carbide, which is in cementite state. The main constituents are of four types. They are ferrite, also five types actually: ferrite, austenite, pearlite, cementite, and ladybirite. Ferrite exists in iron. It exists in two forms. They are alpha ferrite and delta ferrite. Alpha ferrite carbon is soluble. The carbon solubility in alpha ferrite state is 0.008%, which is at room temperature of 727 degrees centigrade. In this state, the iron is appeared like soft and ductile in nature and cannot be hardened by heat treatment process. This is magnetic up to 768 degrees centigrade, and above it becomes non-magnetic. So if we need the magnetic process, we should heat up to only 768 degrees centigrade. And again, coming to delta ferrite, in this phase it is soft and ductile phase. It exists only in high temperature, so it cannot be exist in room temperature. Carbon solubility is 0.1% at 492 degrees centigrade. This is the type of ferrite state in iron carbon diagram. Next, austenite. The solid solution of carbon exists in gamma iron. Carbon solubility is of 2% at 1100 degrees centigrade, 1100 to 1150 degrees centigrade. Soft, ductile, malleable are the properties during this austenite process. Pure hardness, poor wear resistance, unstable in nature. At austenite, it is only stable up to 727 degrees centigrade, and below 727 degrees centigrade it becomes into ferrite and cementite. Most of the steels are heated up to austenite phase, so it's by specific cooling ferrite plus cementite structures are obtained. In coming to pearlite, it is a mixture of ferrite and cementite. It is also called as iron carbide. It has high brittleness here. Pearlite is obtained by cooling the austenite. Pearlite exists in room temperature, whereas austenite does not exist in the room temperature. It has good strength and hardness. Coming to liberate, it is an elastic mixture of austenite and cementite. It contains 4.3% of carbon and falls under the group of cast irons. The below and the above they belongs unto the steel, whereas above properties belongs to the steels, then the liberate belongs to the cast iron. And coming to the temperature point A1, it is a lower critical point where it is pearlite is by heating converts into austenite, and by cooling it converts into a pearlite, which is a reversible equation and reversible process. And whereas A2, it is a Curie temperature loss due to heating or gain due to cooling of ferromagnetism. And A3, upper critical point, ferrite absorbed heating, ferrite nucleation cooling. And ACM, upper critical point, cementite is absorbed by heating and cementite nucleation is done by cooling. And whereas falling austenite is converted into delta iron on heating, and delta iron is converted into austenite by cooling. This is also a reverse process. Eutectic point, where liquid on constant temperature it gives solid plus it gives two solid phases. This is known as eutectic point. In whereas eutectoid point, the solid austenite converts into alpha ferrite and cementite. This is about the temperature points and the eutectic point and eutectal point. And now coming to the graph. Here we iron carbon diagram is transferred into the two phases, and the eutectoid phase is done in the steels, and eutectic side is done on cast iron. Whereas in eutectoid is converted is done in two processes, hypoeutectoid and hypereutectoid. From 0 to 0.8 degrees 8 percentage of carbon, it is known as hypoeutectoid process, and after the 0.8 to 2% it is hypereutectoid process, and again from 2 to 4.3 it is hypoeutectic process, and 4.3 to 6.67 it is hypereutectic process. The phases uh, here in eutectoid process, the solid phase is converted into two solids, and whereas in eutectic process the liquid phase is converted into two solid phases. Here from hypoeutectoid, from 0 to 0.8 perlite plus ferrite structure, perlite plus ferrite process is done, and from 0.8 to 2 percentage perlite plus cementite process is done. This is done for the steels for hypoeutectoid and hypereutectoid. Coming to hypoeutectic, from 2 to 4.3 austenite plus carbonite plus labradorite, and plus from hypoeutectic it is gamma plus labradorite. The main phases in iron carbon diagram are alpha, which is also known as ferrite, and gamma, which is austenite, and delta and cementite. These are the phases which we are seeing. It is alpha ferrite, gamma austenite, and delta, and the liquid phase and the cementite phase. Coming to know here, perlite and ferrite, if both are combined, then it is also known as austenite, which does not exist in the room temperature, whereas alpha ferrite exists at the room temperature. And if we add more percent of carbon, then we observe the perlite plus cementite structure, which is eutectoid point. Perlite and cementite, here gamma plus delta phases appear, and liquid plus delta phases appear in the eutectic point. And the gamma plus liquid iron comes under the eutectic, and liquid plus FeC3, which is cementite, also comes under the hypereutectic, which exists in the room temperature. This all comes under the cast iron category, and this all comes under the steels category. First of all, by drawing the graph, we need to draw the graph of temperature, and we need to draw the graph of temperature and percentage of graph by weight. This is the process of iron carbon diagram, and by seeing here we observe the microstructures which are hypoeutected steel. The microstructure appears like this, which is in the form of ferrite and perlite. And coming to eutectoid and liquid iron, it is a combination of perlite and liquid iron, which is total perlite. And whereas in hypoeutectoid we observe cementite and perlite. These are the different phases in the iron carbon diagram. These are the microstructures. These are the microstructures of iron carbon diagram. Here, by finding the individual phases of the iron carbon diagram, we can know the microstructures of different phases. Here we as shown, it is a hypoeutectoid structure where perlite and ferrite is appeared, and whereas in eutectoid pure perlite is appeared, and hypereutectoid steel perlite and cementite is appeared. This is a iron carbon diagram. The graph has to be drawn as shown on the screen, and if we add carbon less than 2% to the iron, then it is known as steel, and if we add more than 2%, then they are known as cast irons. Thank you. This is all about the iron carbon diagram which I have shown, and these are the different phases and the eutectic point and eutectoid point.